In this video, we'll be talking about prefix sums. So if I were to tell you, sum up, a certain subarray given a really large array, how would you do it? Well, one way you can, just do it. Let's say summing up the third element all the way to the second to last. So this part of the array. Well, one thing you can do is to just go one by one, starting from here, and accumulating the sum until you end up with the answer, which is all fine. And it takes of n time, because in the worst case, you could be asked to sum the whole array. However, what if I want to do this sum multiple times? We'll call it q queries. And each query, if we were to just do the brute force way that I talked about before and just keep summing over, each query is O of n. So the time of this brute force approach would be O of n times q. One motivating question we can ask is, can we do better than O of n times q? It actually turns out we can do a lot better in O of n plus q time, given that we do a little bit of pre-processing. And so how do we do this pre-processing? Well, first of all, we have to basically exploit a part of this problem. And a part of this problem has to deal with, we are looking for a contiguous sum of a subarray. And so if you think about it, for example, what I presented earlier, we'll use the green marker. So this part of the array, right, it's basically the same as this larger part of the array, subtracting this smaller part of the array. So you can think about the array as disjoint sets of this smaller 1, 3 plus the 7, 4, 2, 5 is basically equal to this whole set. Again, not too much to see there. And the magic really comes in the fact that you can kind of represent this disjoint set idea with preprocessing. And so we can actually take advantage of this, since if we are doing multiple queries on the same array, of course, if it's multiple arrays, then there is no helping the time complexity. But if we are doing multiple queries on the same array, we can, again, exploit this fact. And so how do we do that? Well, let's create another array of size n plus 1. And basically, as the name of the method suggests, the prefix sum, keep the running total of the current sum. And again, you can verify it yourself, but the running total of the red line, or all the elements represented by the red line, subtracted by the running total of all the elements represented by the blue line, would be the sum of all elements represented by this green line. And so we can just take O of n time to do some pre-processing as such. So, well, if we query from this beginning, obviously nothing there, so 0. Then next, if we just want the first sum, we just add this current value, this 1 here, to the previous value, which in the case is 0. So we start at 1. Then moving on to 3, 3 plus 1, then 7, 4, and you get the idea. So now that we have this actual, this pre-computed array, although we are using O of n space this time, we can do queries in O of 1 time, because it would be simply an access to the array twice and a subtraction. So for example, again, let's go back to our first thing that we showed. basically we take this 22, right? This represents this big red line here, and then the smaller blue line, 1 plus 3, result is here. So we didn't just take 22 minus 4, and we get the result of this nice array in the middle. We can verify that. So this 22 minus 4 is 18. We get 11 plus 13 plus 5, which is also 18. Okay, so with this in mind, let's implement the code. So this is the problem we'll be working with. Given an array of n integers, AI answer Q queries where the ith query asks for the sum of the array elements with the indices between Li and Ri inclusive. Okay, so let's get to it. First, we have to make sure we read the input correctly. So we have n and q. Let me just change this to q and n to be consistent with the test cases. So now that we've read in n and q, we have to read in the array. So let's use something to represent the array. Let's call it, and then something to represent the prefix sum. I'll call it psum. And again, remember our size is n plus 1, and we know that the first value of psum should be 0. Okay, time to read in the array. So for 0 to n. So this S4 is actually just a macro that I use, which is a simple for loop. And so we can actually, it looks like we don't actually need this array at all. We can just read everything as is. Okay, so in that case, we want to go from 1 to n plus 1. Okay, so psum I would be, like the name suggests again, psum prefix of I minus 1 plus whatever the whatever is passed. So now we have this array ready. Our preprocessing is ready. And so we can do the solve now. So actually solve, we would need this calculate psum array. So let's just do that. This was just a template that I used. So we'll add that argument, pass it in. We'll take a left and a right number from standard output. And now all we have to do is to take the right minus the left, of course, minus 1 because it's inclusive. And then that will end up being our output. Okay. So this looks okay. Let's give it a little test. Let's compile this. Oh. Compile this. Check everything's good. And then I've already copied the sample test case here into a file called test.txt. So let's quickly see if it works. Okay, 15, 5, 10, 15, 5, 10. Yeah. Okay, so it matches. And so again, I guess to triple verify it, we can actually submit this onto the actual Codeforces link, and we see that, yeah, it takes 93 milliseconds. That's it.